Hello and or welcome back. In the previous video we went over the railway track, which is rather important if you haven't watched that already, so I'd encourage you to watch that first before seeing this. In this video I'll be talking about how to get the toy train carriage to actually animate along this track. So let's get started. What we have is basically a box kind of thing for the carriage, and then inside that I've got a couple of nulls containing geometry for these wheel cages. I don't know if that's the actual proper name for them, but that's what I've called them. And I've also got a camera inside here. Don't need the protection tag, but camera inside here, so whenever this carriage animates I can see what's going on without having to chase it along the track. So first of all, let's start with creating a Align-to-Spline. Now I've got this set up already, so this will work nicely when I put the tag on. This is a nice and clean scenario where I plug everything in and it's gone to the start of the spline, but everything's nice and clean. However, there's a chance that, say, if I were to do that on a copy of this carriage, let's see if I was to try and move it back to where it was, give this an Align-to-Spline, everything's looking great, I'm like, right, I'll put the spline in, oh, it's not where I wanted it to go, and then I hit tangential and it's all a mess, we've broken it already, we've not even started. So what I'd recommend, which is what I've done before, is, let's get another copy, this null, put Align-to-Spline on that, plug the main spline in, hit tangential so it orients it along the path of the spline, then put your object in, and if you want to move it within that null you can do, but that way you don't end up messing up your geometry. Anyway, with that out of the way, go back to this. I'm going to start on 1%, so we're on the track, and then frame 400, I'm going to say 99% just so we're not falling off the end of the track as well. And let's scrub it back, we can see it's moving nicely, and it will be moving consistently without any sort of easing issues. If you're having easing issues, look at the previous video, because that should help address any issues there. So we scrub through, and first thing is the wheels are coming off the track. It's moving along the path though, which is what we wanted, and it's facing the direction it's meant to be facing when it turns, so that's good, but the wheels aren't actually attaching, so we're going to address that first. I'm going to see if I can do a cheap and cheerful method first, in which has complete disregard to measurements and whatnot, and then after that I'll do a more reliable version in case you need to make sure that the wheels are at the right distance and stuff. But first I'm going to do a fun version. So I'm going to pull, actually, don't want to make a copy of this. I'm going to keep these measurements noted down, so I'm going to say 8.15. I get a null, just so I remember that for later. I can pull these out and get rid of this Align-to-Spline tag on the main thing. I'm going to get a couple of nulls. I'm going to say Align-to-Spline front, and copy that, paste that here, and set this to back. I'm going to give these both Align-to-Spline tags, and make sure they're both tangential and have the main spline inside them. I can put these inside here, put the front in the front, back in the back, and now these Align-to-Splines are stacked on top of each other, so if I move these, if I clean up these coordinates, and you'll see they'll move on the exact same point, which isn't an issue yet, so we're fine with this. This is normal, this is to be expected. Let's move this forward. I'm going to say 1.5, that's roughly roughly there, so I'm going to say 0.5 there. Eyeballing it, looks pretty decent. So we're part way there, and what you can do is let's see, keyframe there, and then frame 400. I'm just gonna add 90 for the sake of it for now. I'm going to copy this track. You know what I'm just going to paste it in here. So we've got the identical animation on both of them. So they're both inside this object at the moment. However, I'm going to go in the F curve of the back one. And I think it was 0.5 we had it before at the start. So I'm going to select all the points of the animation and then just offset them so they're about close enough. Don't worry if you're worrying about the measurements and stuff, we'll get around to that, but for now, just getting this to do its thing. So if I was to take this camera and plug it inside this front track, or this front wheel cage, see how the animation goes. You can see we've got both of the wheel cages moving nicely, and they're both within the rails, which is great. They're in the track. They're moving nicely. They're at an equal distance because they've got the same animation, just with offset in value, and they both do quite well. We've got a little bit of a bump in the track, and it seems to handle it really well. Everything's good. So the next part is getting this carriage to stick to it. So what we're going to do is create a new null, PSR carriage, because we're going to use a PSR constraint. Go into tags, rigging, constraint, transform. This used to be called PSR, that's why I've named it that. Going to get two targets. If you haven't figured it out already, the front will be the first target, and the back will be the second target. So what this is doing is basically pinning this null between the positions and rotations of these two wheel cages, which is great because now if I keep this selected, move through, you can see the null is positioned between both of them. Not only that, we get a little bit of procedural movement, because if I move the position of this with that null selected, you can see the null moves to ensure that it's always in between those two wheel cages. So all we need to do now is drop the carriage inside, clean up the values here, and then I'm just going to move the camera back under here just to keep things a bit clean. And now when we scrub through this, everything works. So if this is good enough for your usage, then feel free to use that. Yeah, this seems to do quite well. So now I'm going to go on to measurements. Now I'm going to try and do this in a certain way, a very specific way, because it will be used as a precursor for the next video. So if you're wondering why I'm doing certain calculations, that'll be why, and I'll explain at those points why and what I'm doing. But yeah, if we move along this track, you can see this carriage has come off from the wheels completely. That's what we're going to be addressing in the next video. But yeah, I'm going to quickly go over an Xpresso rig for setting up the distance between these. So we had 8.15, that's the distance we wanted between these wheel cages and this carriage. Now normally I would say get the middle point of this, because they're equally distanced from the middle point of this, and it would be we had 8.15 centimeters from the middle here for the front, and then negative 8.15 for the back. So you could work with 8.15 going one way, 8.15 going the other. However, how I'm going to do it is I'm going to take this back position and have the front one relative to the back rather than the center. So this would be 0, middle will be 8.15, and then the front will be 16.3. So that's how I'm going to be doing the math. That's the weird quirk which I wanted to cover. So first of all, I'm going to create a couple of parameters to work with. What am I doing? Userdata, that's one. I'm going to create a group. I'm going to call this Carriage data. And create some data inside that. And first one I'm going to call length of track. It's actually the length of the spline, but I'm going to keep it within context. That'll be, even though it'll be in centimeters, I'm going to be using real numbers in this, so I'll just stick with real for now. We don't want the max limit. We don't want it to be animatable. Then the next one, we want the distance here. So I'm going to call it wheel cage separation. Again, I'm going to use real, get rid of the max limit. I'm going to keep this animatable because that could be quite fun. So now we've got this UI here with length of the track and wheel cage separation. So first of all, we need the length of the track. So I'm going to select the main spline, go to mode, go to project info, right click this text here, copy it, because this is the length of the spline. You need to have this selected as well when you go in here to actually get that. And I'm going to paste it in here. In the wheel cage separation, I had 8.15, but as I said, I'm going to be calculating it from the back to the front rather than the center outwards. So it'll be 8.15 times by 2, so we get 16.3. Now we're going to get an Xpresso tag, and we're going to need the Align-to-Spline null with the data we've just given it. There we go, carriage data, length of track, and wheel cage separation. I'm going to get result nodes in as well, just so we can see what's going on. So here we've got the length of the track, and here we've got the wheel cage separation, which matches these values identically. So that's good, everything's working so far. What we're going to do is we're going to get the back. It's going to be the tag that we're referring to. And we're going to need its position, because this position, or this front one, is going to be relative to this position, so we need this position in here. What we need to do is take the length of the spline and have it translate between centimeters and percentages, because obviously the Align-to-Spline doesn't work with centimeters, it works with percent. We need to try and get some sort of translation between the two. So what I'm going to do is get a range mapper node, and I'm going to get the output, set that to user defined. I'm going to have the input set to percent. I'm going to get the position, plug that into the input. Now, what we want the output upper to be, because the position here in the input is saying where we are currently. The input lower is saying the minimum amount you can go to, and the upper 100% being the maximum amount you can go to. And we've not clamped these, but we could do if needed. Now the lower 0% corresponds to 0, which in this context is going to be in relation to the spline. So this is 0 centimeters on the spline. This at the moment 100% refers to 1 centimeter on the spline, which is not what we want. We want this, the length of the track. So we're going to put that in the output upper. So now we plug this into the result, 7.162. So basically this value here, you know, I'm gonna name these actually before I continue because I'm getting lost already. Yeah, there we go, that was the back one. going to name this one front. So this value here, 0.4629%, relates to, or translates to 7.162 centimeters on the spline. Now we're getting somewhere. We've got the position in centimeters. So what we want to do now is get another calculator node. We're going to get a math node. We've got the wheel cage separation. So we want this position in centimeters, which we have now. Add the wheel cage separation, which is 16.3. So we're going to say this current position, add 16.3, just move that out of the way. And then this is going to output into the front. However, I'm not going to plug it in just yet, because what we would get is the result in centimeters. We need these centimeters to be translated back into a percentage so the tag can understand what it's dealing with. I'm going to delete these animations for now as well, because that's going to confuse things. So we've got these, right? So we just need to inverse what we've done already with the percentage conversion. So instead, the input is going to be in centimeters. So we want this to be in user defined, and then the output, we want that to be percentage. And again, the output upper, oh sorry, this time the input upper needs to be the length of the track, because we want the input upper to be 100%, which is the very end of the track to equal 100%. And then we plug this into the input, so we're converting the centimeters of this new front position into a percentage, which comes out as, there you can see it's just moved slightly there, comes out as that percent, which is really nice, because now if you want to change the measurement between those, say you're working on something and it turns out you're a centimeter out, you can just increase a centimeter and there you go, you've sorted it, and the carriage stays within the middle. Not fully done yet though. Do we still have the camera? There we go. Right, we've removed the keyframes, but I'm going to animate the back because that's the one which is going to be driving everything now. So I'm going to set the keyframe at 0%. I'll put 1. There we go. And then at the end, we're going to say 99%, possibly 98. Don't know. It's 99. Oh, 99 is too far because we're going off the end of the track. See, this is where we could clamp the values, maybe. I don't know if that'll actually fix it. But yeah, if we scrub through, there'll be one notable issue, which is, well, actually no, it seems to work. Everything seems to be fine. Everything's working. Okay. I was actually quite surprised about that. I didn't think it would work as intended. What I was going to do, which is why I thought an issue was going to occur, was that I was going to have this back carriage, instead of it using a PSR constraint, I was going to have it in the back, and then actually I could probably salvage this. I'm gonna salvage this actually. Get rid of the PSR constraints. Position this directly under the back, oriented nicely. Then get rid of the transform, use aim. Then have this aim at the front. This will all make sense in the next video really, so if you're happy with what you've got so far, you can leave content. But if you want to stick around for the next one, this is a bit of a precursor for it. It might explain a bit. So what we have now is this carriage is constantly aiming at the front. It should be at least. Let's just check. Oh, okay, I've put the wrong thing in and may have ballsed things up. Whoopsie daisy. Put the carriage inside that. That's what I meant to do. and there we go. It's just a slight bit more refinement, because as you can see, the carriage is, well, it's going to permanently be pinned on this back one. So it's addressing part of the issue we had before with the carriage coming off the wheel cages, because this one, the carriage is fixed underneath the back wheels, so this can't be misaligned anymore. So we've reduced half the problem. Problem is that the front one, as you can see, the back is nicely locked in place. The front one is still getting offset, which is what we're going to address in the next video. But you know, this, I'd say this is a more reliable method compared to using the PSR constraint as shown before. But you know, if you prefer one over the other, you know, go for it. And again, we can adjust the wheel cage separation, whereas in this case, because we're not using PSR to control its position, it's just offsetting the front one because everything's relative to the back point now. So I'm going to move on to the next video now, in which now you've got a bit of a precursor as to how things are going to work. We'll see about how to address this front wheel issue. So hopefully I'll see you in the next video.